Okay, this is our last part for our dead guys. We're going to start this one with Ernest Rutherford. Okay, Ernest Rutherford discovered the nucleus. Okay, so he discovered the nucleus of the atom. If you remember back at the last video, we had our plum pudding model where there was no nucleus. It was just a big solid ball. He also discovered that the nucleus has a positive charge. All right. He used what is referred to as the gold foil experiment, okay, in which he shot alpha particles. That's the symbol for alpha. Okay, he shot alpha particles at a thin gold film, okay, or thin gold foil. All right. And then he measured the refraction and reflection of the particles. All right. So basically what this looked like, and again, you can Google this and get something that's animated and nice and color and pretty. But basically he had a box. And from that box it's essentially an alpha particle gun. We just shot alpha particles out of it. So he shot alpha particles out. And then he had his gold foil, okay? And then around that gold foil, he had just a nice little barrier around it. And I know that's not the best drawing, but whatever. And what he found was that most of the particles went right through and hit the back, okay? The particles went right through the foil and hit the back, didn't move at all. But what he found is that some of them got reflected or refracted backwards. So there was a small number that would hit, in various spots on this wall around it. Okay, and what he determined was that our atom has to have some small ball of positivity in it. So where most of the alpha particles can pass straight through without hitting it. Okay? And then every now and again, one would come and reflect off or bounce backwards. Okay? So then your atoms sat there next to each other, and again, most of the particles just went right on through. Okay? So what he came up with was the nuclear model. Okay, in which you have a solid nucleus and then electrons around it. But the majority of it is empty space. Okay, the majority of that is empty space. So what would have happened if Thomson, the plum pudding model, was correct? If we look at this, we'll look at it over here and just say, okay, we've got 3 atoms. Actually, let's just say we've got 5 atoms, and they're arranged like this. Okay, and they're all solid. Okay, they're all solid balls of positivity. What would happen if we were shooting alpha particles at it? Okay, There's no empty space. They're just solid. How many of those alpha particles would get through? Okay, and the answer is not very many. Okay, the vast majority of these would be bounced off, reflected or refracted off, and very few, very few would make it all the way through, if any. Depending on how tightly packed or how densely packed the atoms were. Okay, but because the atom is actually mostly empty space, it allowed the vast majority of those particles, those alpha particles, to pass right through. Okay, so we determined that plum pudding model is incorrect. Okay, so we move on to James Chadwick. Okay, James Chadwick, he worked with Rutherford, so he was familiar with his work. All right, and Chadwick discovered nuclear fission. He discovered nuclear fission, and he also discovered the neutron. Okay, so he took some of Rutherford's work, did his own work, and discovered nuclear fission and the neutron. Last guy is Henry Moseley. Hey, Henry Moseley. He also worked with Rutherford, so working with Rutherford was a pretty wise move for these guys. Okay, he determined the positive charge. Okay, determined the positive charges of these nuclei, and he basically found that atomic number gave an element its identity. Okay, and using that information, he reorganized the periodic table. Okay, and when we get into the periodic table, you'll see his name come up again. Okay, and he devised essentially what is periodic law, and an oversimplified definition of periodic law, which we'll get into later when we talk about the periodic table, is that a pattern sets of properties. So if you look at the properties, okay, they create a pattern. All right, and that's how we can organize the periodic table. Okay, that is the final installment of our Dead Guys lecture. So now we have our nuclear model. We're not going to go any further into that. I know there's a Bohr model, and there's one even further than that we know as the most correct today. But as far as we're concerned, this is where we're going to stop. And that's it.